Okay, class, this is part two of our digestion section that we're talking about in week one of our Moodle course. And we're going to continue on with a picture of peristalsis. We alluded to this on the first PowerPoint that I talked about. And here you see that brown kind of football shaped picture there that is going through the digestive system, and that is, of course, a bolus of food. And it's just showing you how that muscular tube opens and closes and kind of gets that bolus to move down that tract. Once it goes down that esophagus, it goes to the stomach. The stomach is a J-shaped muscular sac. It has inner folds called rugae that increases the surface area of your stomach. And what it does is it churns and grinds together the bolus into smaller pieces. Again, we are doing still doing some mechanical digestion of that food, and we are also starting that chemical. So we got chemical and digestion of the food going on here in the stomach. And that chemical digestion is done here. It says the food is mixed with gastric juices. Those juices have the chemicals in them. Those enzymes, those important proteins, and hydrochloric acid. And it is secreted by the stomach walls. HCl, which is also known, which is short for hydrochloric acid, helps break down food and kills bacteria that come along with the food. So any of that bad stuff in there, if there's not too much bacteria in it, your stomach has a built-in mechanism of killing that bacteria because it's got such a high acidic content in it, and so it will kill most bacteria. There's a picture of your stomach. This is a good time to pause again. Take note of those areas that you are not familiar with. And you can see how the stomach is a muscle by the different muscle layers that you see there. And it's a very movable part of your digestive system. It's constantly churning and getting that food to go from a solid to a liquid into very smaller pieces. One of the major enzymes in the stomach is pepsin. And what it does is it converts proteins into peptides in the presence of HCl, which is hydrochloric acid. It also has mucus in it, which lubricates the food and protects the gastric lining from strong digestive juices. Gotta have that protection because remember, even though the stomach secretes that hydrochloric acid, it is still an acid, and you need to have a lining in your stomach to protect it so that that acid doesn't start to eat away your stomach. So what it does is these things convert the bolus into a liquid called chyme or chyme after 4 hours of mechanical and chemical digestion. It turns that solid into a liquid. And chyme passes through the pyloric sphincter into the small intestine. So now that bolus of food has been liquidated, and it passes from the stomach. And the way it does that from the stomach to the small intestine is through that pyloric sphincter. And we got a good picture of it here. You see how the stomach is moving and making that those gastric juices work to break down that bolus. And you'll see over here, this is where that pyloric sphincter is. It's got to open up to allow you to get that digested food into your lower intestine, or your small intestine, excuse me. So your small intestine, even though it's called the small intestine. It is actually the longest part of the intestine in your digestive system. It's about 20 feet long, and it's coiled up to beneath the stomach, and it has three parts. You got the duodenum, which is the upper part, or duodenum, upper part about 10 inches, connected to the stomach. So that's the first part of your digestive small intestine. This is where the digestive juices from the pancreas and the liver combine with the chyme, which was that food, or chyme, making it thin and watery. And then from there it goes to the jejunum, which is about 8 feet long. And then finally it goes into the ileum, which is the longest part of the small intestine, which is approximately 12 feet long. And it's called the small intestine because it's got a smaller diameter than that of the large intestine. And here we go. Here's a good picture of that small intestine and what it looks like in real time. There on the right, you will see all the folds in it, and it's kind of fleshy colored, but these folds are necessary because it increases the surface area of the intestines so that more food can be digested. And this is, of course, the greatest amount of digestion absorption does happen in the small intestine. Time-wise, it takes about 4 to 8 hours to complete its journey. The mucosa, or the inner wall, they secrete several enzymes that act on the food to allow absorption to occur. Where the pancreatic enzymes are emptied into, that pepsin that we talked about earlier, and digested nutrients are absorbed through the intestinal walls. That's why it's important for it to be so long, because the more surface area you have, the more times it takes for food to get through, the greater the amount of absorption can occur. And so absorb materials across the mucosa into the blood, then other parts of the body for storage or further chemical change. So once it comes out of the small intestine, those digested nutrients go to the parts of the body where they are needed. And I kind of alluded to this on that picture, the real-time picture. The small intestine has those folded inner walls, and they're covered with finger-like projections called villi. If you're looking at the singular pronunciation, that is the villus. Each villus has tinier projections called microvilli. So each little finger-like projection has little teeny microvilli on them, and again, that is to increase the surface area so that the maximum amount of absorption can be can happen through the small intestine. The villi and the microvilli increases the surface area of the small intestine for great absorption. I just alluded to that. And of course, peristalsis is the mechanism which moves the undigested food to the large intestine. And here's a good picture of that, and you'll see it. You've got the more solid piece here, and then once it starts to break down into more of a liquid form, you'll see that it'll spread out, and in these areas all have the villi in them and the microvilli on top of those. So all of this area, it stretches out that chyme, and it allows for absorption to occur. And mixing segmental contraction that occurs in small intestine. And secretion is lubricate, liquefy, and digest. And digestion is the mechanical and chemical breakdown of that food. So we've got these three things happening here in the small intestine, which allows that food to get absorbed as nutrients for the body. Okay, and elimination, again, we'll talk about that in the excretory system. That's basically anything that your body cannot use. Uh, you are going to have to make it, the excretory system will make this chyme turn back into more of a solid state, and so then it'll be removed as feces from the body or urine. Then we get to the large intestine. We're moving down the digestive tract here. It's also known as the colon. It's a larger diameter, but it is shorter. It's only 5 feet as opposed to the small intestine being 20 feet long. But it's called the large intestine because of that large diameter. And this is where water absorption occurs from the undigested food, making the waste harder until it becomes solid. So you're going to start to get rid of that water from that chyme and make it more solid so it can be prepared to be excreted. And that takes about 10 to 12 hours for that to occur. Here we got a good picture of the small intestine. And there is the ascending colon, the transverse colon right here, coming down, the descending colon, and then again, and then this will be the anus where all of the feces will come out of. And this would be a good part for you to pause this and take a minute to look over all these areas in here and just get a good mental picture so you can study for yourself. So in the large intestine, like we talked about, waste is pushed into the expanded portion, which is the rectum of the large intestine. And then solid waste stays in the rectum until it is excreted through the anus as feces. And the appendix just kind of hangs out on the right side of the large intestine. We're not really sure what the appendix does, but it's still there, and sometimes folks will have to have that appendix removed. All right, again, we're going to go over those accessory organs. What do they do? Of course, they produce or store enzymes that helps in digestion. Those come from the liver, which is the largest gland of the body. It does a lot of things. The liver is very important, and it also filters our blood. It stores vitamins A, D, and K. A, D, E, and K, excuse me. And it stores sugar and glycogen. And it produces bile, which is stored in the gallbladder. It's a watery greenish substance, which gives feces its color. I talked about that. And the way that that is connected to the gallbladder is via the hepatic duct and the cystic duct. And you can look back on those pictures and you'll see it on there. The gallbladder, it stores bile in between meals. Also secretes bile to the duodenum through the bile duct during mealtime. So it starts to get that going while you're eating. So what does bile do? Well, it contains bile salts, pigments, cholesterol, and phospholipids. Basically, it's going to emulsify those fats that you eat, break them down. It is not an enzyme. Bile is not an enzyme. It is an emulsifier of fat. Pancreas produces a juice that contains enzymes, amylase, and insulin to break down carbohydrates, fats, and protein. It does that through the pancreatic duct. And then again, we'll look at that path of digestion, starting from the mouth, going to the pharynx, from the pharynx to the esophagus, to the stomach. Then from the stomach, it goes small intestine. Then from there, to large intestine. And then, of course, it is excreted through the anus. Real quick, as you ponder these things that you've just learned, I want you to do this assignment here and turn it in my Dropbox. Just to do a quick chart here, you're going to have to do a little research and make a table about the different digestive enzymes, the substrates, and the products that are made from these different glands, which is the salivary, gastric, pancreas, and the intestinal glands. And that'll do it. I thank you for your time. Sorry I went over a little bit, but hopefully this will help you in your quest to know and understand the digestive system. Thank you.